NEC Article 250.4 first states that metal raceways, cable trays, enclosures, frames, fittings, and other metal non-current carrying parts of electrical equipment, including portable and mobile homes, and fences and metal supports associated with photovoltaic systems shall be effectively bonded to the grounding system. This requirement is crucial for electrical safety, aiming to provide a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. The purpose of bonding is to minimize the risk of electrical shock by ensuring that all exposed metal parts of electrical equipment are at or near ground potential. This reduces the potential difference between these parts and the earth, making it safer for individuals who may come into contact with them. The code emphasizes the need for effective bonding to prevent dangerous voltage gradients and to ensure that fault currents can be safely conducted back to the power source. The term effectively bonded is important because it implies that the connection must be reliable and capable of carrying the anticipated fault current without excessive voltage drop. This necessitates the use of appropriate bonding conductors and connectors that are properly sized and installed. The grounding system, to which these metal parts are bonded, is a critical component of the overall electrical safety system. It provides a reference point for voltage and helps to stabilize the electrical system by minimizing voltage fluctuations and transient voltages. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding electrode conductor that connects the electrode to the electrical service equipment. The bonding requirements extend to various types of metal parts, including raceways, which are conduits used to enclose electrical conductors, cable trays, which are used to support cables, enclosures, which house electrical equipment, frames, which provide structural support for equipment, and fittings, which are used to connect different parts of the electrical system. The inclusion of portable and mobile homes in this requirement underscores the importance of bonding in all types of electrical installations, regardless of their size or mobility. A specific mention of fences and metal supports associated with photovoltaic systems highlights the increasing prevalence of these systems and the need to ensure their safety through proper bonding. Mike Holt interprets NEC 250.4 to mean that all structural steel used in construction, including in larger homes, must be bonded to the grounding system. This interpretation is based on the understanding that structural steel can be considered a non-current carrying part of electrical equipment, especially when it is associated with photovoltaic systems. The rationale behind this interpretation is that structural steel, if not properly bonded, can become energized during a fault condition, posing a significant electrical shock hazard. By bonding the structural steel to the grounding system, any fault current can be safely conducted back to the source, tripping the overcurrent protective device into energizing the circuit. This interpretation aligns with the overall intent of the NEC to ensure electrical safety and to protect individuals from electrical hazards. It also reflects the growing recognition of the importance of bonding in modern construction, where structural steel is increasingly used in various applications. However, it's important to consider that interpretations of the NEC can vary, and there may be differing opinions on the extent to which structural steel must be bonded. Some may argue that structural steel is not always associated with photovoltaic systems and therefore does not always need to be bonded. This argument is often based on the specific circumstances of the installation and the perceived risk of electrical shock. However, the NEC does not make any exceptions for structural steel that is not associated with photovoltaic systems. The code's language is broad and inclusive, encompassing all metal non-current carrying parts of electrical equipment. This suggests that the intent of the code is to require bonding of all structural steel, regardless of its association with photovoltaic systems, unless there is a specific exception or exemption provided in the code. The interpretation that all structural steel should be bonded is further supported by the fact that structural steel can serve as an effective path for fault current, especially in large buildings where it forms a continuous network of metal. By bonding the structural steel, this network can be utilized to enhance the overall grounding system and to provide a more reliable path for fault current. This can improve the performance of overcurrent protective devices and reduce the risk of electrical shock. Moreover, Bonding structural steel can help to minimize the effects of electromagnetic interference, which can be a concern in modern buildings with sensitive electronic equipment. The steel can act as a shield, reducing the amount of electromagnetic radiation that can penetrate the building and interfere with electronic devices. As an electrical inspector, the responsibility is to enforce the NEC and to ensure that electrical installations are safe and compliant with the code. Given the potential risks associated with unbonded structural steel and the broad language of NEC 250.4 FR, it is recommended to continue to require contractors to bond all structural steel used in construction, regardless of whether or not it is associated with photovoltaic systems. This approach is consistent with the intent of the NEC to provide a high level of electrical safety and to protect individuals from electrical hazards. It also aligns with the growing recognition of the importance of bonding in modern construction. In cases where there is disagreement or uncertainty about the interpretation of the NEC, it is advisable to consult with other experts, such as electrical engineers or code officials, to obtain additional guidance. It is also important to stay up to date on the latest revisions and interpretations of the NEC, as the code is periodically updated to reflect changes in technology and best practices. Furthermore, it's crucial to document the rationale behind the decision to require bonding of structural steel, and to communicate this rationale clearly to contractors and other stakeholders. This can help to avoid misunderstandings and to ensure that the bonding is performed correctly. The documentation should include references to the relevant NEC articles and any supporting information or interpretations. In conclusion, the interpretation and application of NEC 250.4 FR regarding the bonding of structural steel can be complex and may involve differing opinions. However, given the potential risks associated with unbonded structural steel and the broad language of the code, it is generally recommended to require bonding of all structural steel used in construction. This approach is consistent with the intent of the NEC to provide a high level of electrical safety and to protect individuals from electrical hazards. It is also important to consult with other experts, stay up to date on the latest code revisions, and document the rationale behind the decision to require bonding.